Welcome to our channel. In today's video, we are diving deep into one of the most essential tools in any developer's toolkit, breakpoints. Whether you are a beginner or a seasoned programmer, understanding how to effectively use breakpoints in Java can significantly improve your debugging skills. First, let's understand what a breakpoint actually is. A breakpoint is a marker that you can set on a line of code, which will pause the execution of your program right there. This allows you to inspect the state of your application, including the values of variables, the program's call stack, and other critical information. Now, let's take a moment to see how we can set breakpoints. I'll be using an integrated development environment, or IDE, called IntelliJ IDEA for this demonstration. If you are using a different IDE like Eclipse or NetBeans, the steps might be a bit different, but the core concepts remain the same. Here is a simple Java program that we will use for our example. This program is straightforward. It adds two numbers and prints the result. However, if something doesn't work as expected, we need a way to troubleshoot it. That's where breakpoints come in. Let's set a breakpoint at the line where we call the addNumbers method. To do this in IntelliJ IDEA, just click on the left gutter next to the line number. You should see a red dot appearing, indicating that a breakpoint has been set. You can also manage breakpoints from the Run menu. Navigate to View Breakpoints, and you'll see all the breakpoints you've set, allowing you to enable, disable, or remove them as needed. Now, let's run the program in debug mode. You can do this by clicking on the bug icon in the toolbar, or by using the shortcut Shift plus F9. Once the program execution reaches the breakpoint, it will pause, allowing us to inspect the current state. When paused at the breakpoint, you can examine the variables in the Variables window. Here, you'll see the values that have been assigned to each variable. You can expand objects and collections to inspect their contents. If you want to inspect the call stack, look at the Frames panel. This shows the method calls that led to the current point of execution. You can see the hierarchy and navigate through the methods to better understand your program's flow. Let's take a closer look at our addNumbers method to see how we can inspect the values that are being passed to it. We'll set a breakpoint inside the method as well. Simply click in the gutter next to the return statement. Now, start debugging the program again. Once execution reaches the addNumbers method, it will stop at each breakpoint, allowing you to step through the code line by line. This is done by clicking the Step Over button or pressing F8. With debugging, you can manipulate variable values live. For instance, you can evaluate an expression or change variable values right from the debugger. This can be helpful if you want to see how changing a variable affects the program without modifying your code. To evaluate an expression, you can simply select the variable or expression, right-click, and choose Evaluate Expression. This can help you quickly test and verify calculations. Let's talk about conditional breakpoints. These allow you to set a breakpoint that only triggers when a specific condition is met. This can be useful for avoiding unnecessary stops in the debugger. Right-click on the breakpoint and select Condition. Here, you can enter an expression that must evaluate to true for the debugger to stop. For instance, if we only want to stop when a is greater than 5 within our addNumbers method, we would set the condition to a greater than 5. This reduces the number of times the breakpoint will halt execution, making our debugging session more efficient. Another useful feature is logging breakpoints. Instead of stopping execution, you can configure a breakpoint to log a message to the console each time it's hit. Right-click the breakpoint and select Log Message. This can be handy for understanding the flow of your program without interrupting it. Having learned about basic breakpoints, let's also explore exception breakpoints. These let you pause the program execution whenever a specific exception is thrown. This can be extremely useful for tracking down issues. To set an exception breakpoint in IntelliJ, open the Run menu, select View Breakpoints, and click the plus icon. Choose Java Exception Breakpoint and specify the exception type you want to catch. This way, you'll be alerted whenever that exception occurs during program execution. Let's create a simple example where we will force an exception by dividing by 0. Here is the modified version of our program. In this example, if we set an exception breakpoint for arithmetic exception before running the program, we will hit the breakpoint when the exception is thrown. This allows us to inspect the state of the program right at the moment it encounters the issue. Let's talk about how to disable breakpoints. When you no longer need a breakpoint, You can disable it by unchecking it in the View Breakpoints menu or by clicking on the red dot in the gutter again. Disabled breakpoints will not interrupt execution, so you can run your program without them, but keep them for future use. And if you want to remove breakpoints altogether, simply right-click on the breakpoint in the gutter and select Remove Breakpoint. This is particularly useful for keeping your code clean and free of unused breakpoints. As a quick recap, we've learned how to set traditional breakpoints, conditional breakpoints, logging breakpoints, and exception breakpoints. We've explored how to step through code, evaluate expressions, and modify variables during a debugging session. Understanding and using breakpoints effectively can drastically change how you debug and understand your applications. It's not just about fixing errors, but truly grasping how your code operates. Now, let's wrap up this tutorial. If you found this information helpful, please give us a thumbs up and subscribe to our channel for more awesome tutorials like this. If you have any questions, or if there's a particular topic you'd like us to cover next, leave a comment below. Thank you for watching, and happy coding! Remember, debugging is not just about finding errors, but also about understanding your code better. Until next time.